So yeah, hello guys. We are discussing here for the latest Codeforces round 964. So we will be discussing from A till G1. So let's go to the first problem. It says that you are given a positive integer of two digits, and we need to find the sum of its digits. So it's basically brute force problem in which you can just do like here you can see 7 is 14 and 2 1 3 4 is 12. So that's what we need to find out. So what we can do here, like we can run a while loop and until this number is greater than 0, we will take the modulo 10, which will give us basically the last digit of that number, and we will add it to the answer. So if I show you my code, then here it is. What I tried, like I inserted as answer 0 and while n is 0. I added into the answer and modulo 10, which gives the last digit, and certainly divided 10 by 10. That last just return the answer. So let's go to the next one. This was a little bit tricky. Like we have given cards which has values 1 till 10, and each player receives two cards. So like basically the first and the second, but the first person has the first two cards and the second person has the last two cards. Okay. So we need to select. We need to find the number of ways to select in such a way that like both these cards. Like if the first person picks three and the second person picks two, then first will be winning, and in the second chance, the first will be picking up eight, and the second person will be picking up six. So here you won two moves. You won two turns, right? So here the score will be 2-0. So similarly, one more thing can happen, like if two let's consider this one and one are equal, and here we will be having three, and here we will be having, let's say, one again. So what we can see here, like if this one and one are equal, then one match will be tied, and the second one, this one and the last, this three and this last one. So the score will be 1-0. So again, the first person is winning. So basically, what are the possibilities? Like the winning strategies that can happen will be 2-0 or 1-0, right? So let's go for this one. So was my solution in the contest. So if these are the conditions where the first player will be winning in 2-0, right? The first person's score will be 2 and the second person's score will be 0. And in these conditions, the first player's score will be 1 and the second player's score will be 0, right? So we need to consider these situations. So these are all the winning situations of the first player if we consider. So yeah, that's the case. So most of the people initially got confused with this 1-0 case. Like if A equals to C and B is greater than B. So this match got tied, and in the second chance, the first person won. Right. Similarly, here, if A is greater than C and B equals to B, and similarly, if A and D pair up and B and C pair up, so if B is greater than C, I have multiplied it with 2 because this this situation can be reverted also. This situation can reverse also. Like if A is paired with B and A is equal to B, and B is paired with C and B is greater than C, then it may be possible that the first person first picks up B and the second person picks up C. So this B is greater than C before A equals to B. That's why it is multiplied with 2. Right. So let's go to the third one. So it was basically implementation based problem. Like we are given intervals li, ri, and an integer s, which is the time that the user needs to solve. So you just need to find a continuous interval of time s. So we are given n number of intervals, and this is the total time. This is the time he needs to solve. So if you see this queries these time intervals. So before the first interval itself, user has a time of 3 units, and after this last interval, user has zero time because that last interval is ending at 10, and also we have only 10 minutes in a day as given in the question. Like here you can see day only has m minutes, right? So similarly here you can see if it needs 3 units of time to solve, and after 7, 8, 9, and 10, since only 10 minutes are available in a particular day, so after 7 it will be at 9 and 10, during which it will solve. So for this I coded it like I have taken input, and I have taken a last variable and the flag value, which basically marks if we have captured an interval of size greater than or equals to s or not. So we just take input of L and R. So if L and S has a gap of at least S, then we will mark this flag as 1, and we will mark the last as the ending point of that interval. Right. So at last, it might be possible, like in this case only, it is possible that after the last interval, the remaining time can be used for solving. Right. So for that, this case is there, and at last, if we have found such interval, then we will just print yes or else print no. Right. So let's go for the fourth one. So here it is. Uh, you just need to find whether p is whether this second string maybe subsequence of the first string or not by replacing those question mark with any of the English alphabets from A to Z. So if you see here, these first three question marks can be replaced with X, B, and X. So this string, and it doesn't matter like whatever you can place here, or else you can choose these three question marks and replace with xdx. So it's basically a two-pointer approach if you think about the solution. Like here you can see if it is A, B, C, D, and E. So we have already found A, B, right? We have already found A, B, and E is also there, which is at the in there. So what we do, like we take two pointers, first at the first string, first at the starting of the first string, and the second pointer at the starting of the second string. And if we, like if I say my code in this one, just take two pointers and run a while loop. So both if both of them are matching, then just increment both of them. And if s of I is a question mark, then definitely s of I will not be equals to t of j, right? Because the second string does not contain any question mark. So we will mark this question mark as this character, right? We will make this question mark equal to this character and move on. So that's what we are doing. S of I, we assign T of j, and we increment both I and j, right? Or else what we do, we still need to find this character. So what we will be doing, we will be skipping that letter. Like let's say here some D would be there. So after A and B, we need to find C, but here we have D, so we will skip that character. That's why this is I plus plus is there. And after completion of that string, like let's say we haven't completed our second string, right? But we have completed our first string because one of them has to end after this while loop, right? So if our second pointer is still somewhere in between the ends of the second string, so we haven't found any subsequence that can match our second string. So we will simply output no. Or else, while let's say the second output is gone, like we have completed the second string and still our iteration over the first string is remaining. So that basically means like we have found the subsequence in the first string and still some letters are remaining. So we will traverse through the first string and mark all of the question mark with some random character. So I have chosen A and just skip those letters which are not question mark. And at last, you need to print just you have found an answer. So just print yes and yes. So that finishes the fourth solution as well. Let's go for the fifth one. This was an interesting problem, I would say. Yeah. So on the board, you have some range L to R that is ranging in between 1 to 10 to the power 5. So you are given two integers in that range, and all those integers are being written on that board, right? And in one chance, what you can do, you can pick up two integers and multiply one of them with 3 and divide the another by 3, right? So you need to find what is the minimum number of operations that you need to perform to make all of them equal to 0, right? And so let's see how it can happen. So if you take this example, 2, 3, 4, 5, 6. So what we can do, we can divide it by 3 and we can multiply it by 3, right? Because you need to pick two integers at once, right? So while we divide it by 2, while we divide it by 3, it becomes 0 and this becomes 9. So after that, what we can do, we can always multiply it with 3, right? Because 0 multiplied with anything remains 0. So that does not count like only, and only it will be remaining same and the other integers that we are operating upon. So that will be getting divided by 3, right? So it will be getting divided by 3. So 9 divided by 3 will again be 3, right? So, what basically it shows, like these integers will remain same after like let's say the first integer takes x number of steps to become 0 when divided by 3 continuously, right? So, for achieving this state, for achieving like the first integer becomes 0 and all of the remaining remains same. So for that, x into 2 number of steps we will be using, right? So that makes the case like it will be 0 after that 3, 4, 5, and 6, right? Now we have the case like to make all of the zeros by dividing by 3, and the other number we are gonna pick will be this 0, right? Because we will be multiplying it by 3 and dividing rest of these by picking one by one of them and dividing by 3, right? So this will be taking the least number of steps because we are trying to divide all of them. And for the minimum number of moves, we have chosen this, the first integer to make 0 at first, right? and we will be adding this x into 2 in the answer initially, right? So now, if you try to go through each of them one by one in every single step, then it will be lead to TL. So what you can do, like what my solution was, like initially, if you are taking x number of steps to make the first integer zero, so you will be adding x into 2 into the answer, as this number also get multiplied by 3x number of times, right? So you will be dividing it by x number of times, it by 3. So uh, that x will again be added into the answer, right? So basically, x into 2 will be our initial answer. So what about the rest? So if you observe carefully, like these numbers, if 4 by dividing it by 3, it takes 2 steps to become 0, right? So from 5, 6, 7, 8, also these numbers also take 2 steps, right? So this continues until the next power of 3. And what is the next power of 3 after 4? It is 9, right? So after 9, it is getting changed, right? So we can use this theory. So 9 takes count of 3 to become 0, right? So after 3 steps, this 9 will become 0. So that we can use here. We can just find the next power of 3 after that number, and we will multiply like whatever count it takes to make it 0, multiplied by the this range, like how many numbers are in between the next power of 3 from that current number. So currently we have, like, let's say from 4 we are starting, so from 4 till 9, so uh, from 4 till 8 we have 5 numbers, so we will multiply 2 with 5, right? Simply, and we will jump to the next power of 3, that is 9. And here we need 3 steps to make it 0. So we will again, like, from 9 till 26, right? Because the next power of 3 is 27. So from 9 till 26, all the numbers will require 3 steps when dividing by 3 to make them 0, right? So yeah, that's what my solution was. So let me show you my code for this. We have taken the input L and R, and we have assigned a number num to L, and while that number is greater than 0, we are counting, like, for the first number how many attempts it will take to make it 0 by dividing when dividing it by 3, right? And we will be adding that count into 2 into our initial answer, and we will start from L plus 1. So while this I is less than equals to R, so if perfect of I, this checks whether I is a perfect power of 3 or not. So how we are checking it? We are just taking this value, which is log n base 3, basically. Log n with base 3, right? So, and like, let's say it gives us a value num, so we will multiply 1 with 3 num times and check uh, whether it is equal to the original number or not. You can verify it your own ways also, like without using logarithm, but I have done this way. So basically, this perfect of I checks, like, whether I is a perfect power of 3 or not. If that is the case, then just increment this count as we have calculated here, like the previous number, how many count it will take to make it 0 when divided by 3 continuously. So we will increment that count and add that count into our answer and just increment our I, right? Or else, if it is not a perfect power of I, then it will also require count number of steps as we have calculated previously, right? So just calculate the next power of count, like the next power of 3. That what we are taking in, that's what we are calculating here. Like if the count is this much, then what will be the next power of 3? So we simply multiply with 3 into 1 till this count is greater than 0, and at last we are returning this result. So we are calculating the next power of 3 and stored it in nums. And so from there, what we are calculating, like how many numbers are there in that range. So if r is less than minimum, then it is r minus I plus 1, or else it is just num minus I, because we are calculating from, like I have shown you here. If 9 is the next power of 3, then we are calculating from 4 till 8 only, right? So this will give us like basically 9 minus 4. So it will be 5 numbers are there: 4, 5, 6, 7, and 8. So that's what we are doing here. And at last, you just print the answer. So since constraints are very much less in this problem, like 2 into 10 to the power 5, you can also use prefix sum. But for larger constraint, you can go for this solution. Also. Let's go for the F. So we have been given an binary array of length n, and you have to take all the subsequences of length k. Here it is mentioned that k is odd, and you need to find the median. So like basically you take all the subsequences of length k from that array and sum up their median, and you need to tell what is the sum of those medians, right? So let's observe carefully. Like if if the subsequence length is 3, then for median to be 1, median being 0 is not necessary to be counted, right? Because it won't contribute to the total sum if the median is 0. So we need to find such subsequences whose median is 1, right? So what can be the possible cases? Like let's say we are having k equals to 5, right? So if we are having k equals to 5, we need to have at least k plus 1 by 2 number of ones, right? Like let's say if k is 5, then we need to have only, we must need 1 in these 3 places, right? We don't care about what are the digits in these 2 places, but these 3 places must be 1, right? Because for finding median, what we need to do, we need to sort that subsequent. We need to sort all the elements in that subsequence, right? So after sorting, all the ones will be after all the zeros. So the last 3 digits will must be ones, right? So let's say we have 7 ones and 3 zeros, and n is 10. So what we can, like how many ways it will be for arranging a subsequence of length 5 having a median 1. So these three must be ones, and after that there might be the case that this is also one, right? And this is also one. So we need to calculate, like from having 7 ones, how many ways are there to calculate 7C3, right? Like from 7 ones, we have to pick 3 ones. So how many ways would be there? It will be 7C3, and the rest of them, the rest of them will be zeros. Like we have only picked 3 ones. So these 2 places we can have zeros, right? We may have zeros here and there, right? So these 2 zeros must be coming from these all total number of zeros. So we will be having 3C2, right? So this is the case where we are having three ones in a subsequence. It might be possible that we are having four ones and one zero only. So in that case, it will be 7C4 into 3C1, right? Uh, yeah, 3C1. And similarly for all five ones. For all five ones, it will be like 7C5 into 3C0, right? So these are the cases in which we can have a subsequence of length 5 having a median 1 because they can only contribute to the sum. So now for this combinatorics code, you can go through the CP algorithms tutorial or that article, and you can find the code here. So basically, this NCR is basically n factorial divided by n minus r factorial into r factorial, right? So how we calculate it, you can go through the article. I will provide the link in the description. And yeah, let's go for the G1. So G1 was basically an interactive problem. So it says like you are given two numbers A and B. Like you have to ask the system two numbers A and B, and you will be getting the sum of the rectangle, the area of the rectangle, right? Like A into B, you will be getting, and you need to find a particular value x. So if you ask some number y that is less than x, then it gives you the exact length y, right? And if you ask for some length that is greater than x, then it will return you basically a length greater than 1, right? So it's a basic implementation of binary search, as most of the interactive problems are using binary search. So the first idea I got was to use binary search. Let me show you my solution here. So it basically says that x can range in between 2 to 999, right? So here you can have your low and high values as 999 and your answer as 1, right? So why binary search is being used here? As you can see here, till y is less than x, you are having that correct length, right? So like let's say if your x is 4, right? So if you ask for y equals to 1, it will give you the correct answer, like the correct length 1 only. If you ask for 2, it will give you correct length. If you ask for 3, then also it will return you the correct length. But when you ask for 4, it will give you answer 5 because the fourth index is at 5. Here you can see that. So what I used, like A and B are separate. So what I tried, like take one of them as only one, and the other as something else, like the mid value. So that's what I am querying here. I have taken the mid as low plus high by 2, and I am querying 1 and this mid. So I have taken A as 1 and B as mid. So what it will be basically returning the area of the rectangle having length 1 and width of mid, right? So the area will be mid only, right? So that's what it will return. So I have taken input, and if that num is less than equals to mid, that means that mid is within the range of x, is less than the range of x. So just ensure that you take take count of that. I have stored it in answer variable, the mid, and you need to go through the right half, right? Because you are still before that x range. Or else if you get a number that is greater than mid, then it means that you are greater than or equals to x. So you need to go to the left half, right? And at last, we will be getting the maximum number which is less than x, right? So what will be x? X will be just answer plus one, right? So since this query